All right, welcome back, mathematicians. What we're going to do this time is what they call a binomial expansion using Pascal's triangle. So what we're used to is multiplying binomials by hand. So in this case, we have a 2x plus 1. And we would usually write it out 2x plus 1 cubed, because I'm talking about a cube in this case. And we'd write 2x plus 1 times 2x plus 1 times 2x plus 1. But instead, this time, we're going to take a little bit of a shortcut and go a different route using Pascal's triangle, and it's going to be a lot faster for us, especially when we get to fourth and fifth order polynomials. Okay, so in this case, I'm going to try to find this volume of a cube. So if I wanted to find like maybe the cost of paint in this cube, I would just multiply it by a constant. But for now, I just want to find the volume. So this is going to be length times width times height, which is going to be 2x plus 1 times 2x plus 1 times 2x plus 1, or 2x plus 1 cubed. So what I'm going to do here is first look at my Pascal's triangle, right? If we don't know how to make this, it's not too bad. What you do is you start off with a 1, or these 3 ones up top, and every subsequent row is made by adding the numbers above it. So again, start with a 1. 1 plus 1 is going to give me 2, and end with a 1. And again, start with a 1. 1 plus 2 is 3. 2 plus 1 is 3. And end in 1. Same thing. So again, we see that next pattern one more time. Start with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And end with a 1. So this is for order x, plus something squared right here. This is for something cubed right here. So this is the row that we want right here. Okay, so I'm going to try to do things in different colors here. And what we're going to be looking for is for patterns, okay? So my coefficients are 1, 3, 3, 1. So those always go first, right? So I go 1. I'm going to leave myself some little bit of space here. Plus 3. Plus a little bit of space. Plus 3. Plus 1. And then what I'm going to do is I'm going to write this other term in a different color. So So what we should notice is that for my red term, or sorry, for black terms first, black terms come directly from my Pascal's triangle, 1, 3, 3, 1. My red terms, my 2x, I put inside parentheses. I go to the third power first, second power, first power 0. And so those exponents go down by 1, right? And then for my blue term, I should go, I count the other direction, right? So I start from 0, 1, 2, 3. Okay? And what we should notice is that these are kind of opposite and they go by a pattern, right? And so what I'm going to do now is just simplify, right? I'm going to do it in black. I have 1. Anything to the 0 power is going to give me 1, so this is a 1. Maybe I'll write these guys. This is a 0 power, so that goes to 1. And so I have 1 times 2x to the third. So I'm just going to write that term like this so we don't get confused. And then I have 1 times, let's get rid of the 1's first. 2x squared. And that's not 1, so I have 3. Oh, there's a 1 right there. I can get rid of that guy. Usually we don't write things times 1, so this is 1 times 1 times 1 again. So that's just going to be 1, okay? This is the part that students seem to have problems with. When I have an exponent to some term here, I have to hit both of those terms with the cube. So I have 2 cubed, which is going to be 2 times 2 times 2, or 8. This is going to be x cubed. This is going to be 2 times 2, or 2 to the fourth power, or 2 squared, or 2 and x to the second power. So I'm going to have 3 times 4, which is going to be 12x squared. 3 times 2 is going to be 6x. And then finally plus 1. So again, we can kind of see how this is going to be a lot faster than writing this term out 3 times, multiplying them together. And in fact, if our algebra skills are up to it, we could probably skip this middle step here and go directly from this row to this row. Depends on how easily we see these ones, okay? So thanks for listening. I'll catch you on the next video.